Welcome to another Cycling video. We're doing number 43, page 647. So in this one's going to be very similar to problem 41 in the sense that it is going to give us some initial numbers, and we are going to have to figure out things after it reaches equilibrium. So we're going to have to do that ice table again. So we have 2 of the SO3. It decomposes, there's an equilibrium with 2 SO2 and O2 for problem 43. We of course are going to have to do our K expression over here where we're going to have our O2 times our SO2, and that is going to be squared over our SO3 on the bottom, and you know I'm not good at brackets here, squared. Now, like in 41, it's going to give us moles. But this one is not quite as easy in the sense that in 41 it was in a 1 liter flask. In 43 this is in a 3 liter flask. So again, if I know my molarity is again moles per liter, I'm just going to take the moles that they give me divided by my liters. So the two things they give me that the SO3 here is that I've got 12 moles of that. So what I'm going to do is I'm going to do the 12.0 moles before I come over here and divide that by my 3.0 liters, and then of course it's 4.0 molar there. 12 divided by 3 is 4. So that means that I start off with 4.0 molar of the SO3. That is what I have initially there. So this is my initial. So to look at the change, it tells us that at equilibrium then, that 3 moles of the SO2 is created. So again, I don't want moles, I need the concentration. So I'm going to take that 3.0 moles, and again, it's still in the 3.0 liters, and that's going to equal our 1. That is what this guy is. So initially, those guys are at 0. So our change is that this guy is going to be a plus 1.0 molar. Now here's where we have to be really careful. This one has coefficients. The last one was all 1 to 1 to 1 to 1 to 1, and so what happened to 1 straight up was what happened to that. But I do notice that between the O2 and the SO2, this guy is a coefficient of 2 and this guy is a coefficient of 1. So it means that this is half the amount of this. So if this is 1 molar, that means that this is going to be half of that, which is of course 0.5 molar. Now, if I'm looking over here, because this has a coefficient of 2, you could either think of it as being 2 times this amount, or, since this also has a 2, the same as this. So this guy, remember on the reactant side, I'm going to subtract that. It's going to be minus our 1.0 molar. So then at equilibrium, I have 4 minus 1, which is our 3. And then this is at 1, and this is at 0.5. Okay, so then I'm going to take these guys and I'm going to plug them into our equilibrium expression up here. So our K is going to equal our O2, which is 0.50, times our SO2 squared, which this is nice, 1.0, and we're going to square that, ends up being 1.0. But the bottom, do notice our SO3 is 3, and that guy also has to be squared. So essentially you're going to end up, if you can show all your work here, 1 squared is 1. 1 times 0.5 is going to be 0.5. And on the bottom, 3 squared is going to be 9. So if you take 0.5 divided by 9, should be, So our K in this case is 0.05, and that's repeating. So I'm just going to put 5. You can put 5, 5, 5, 5, 5, or 5, 6. So that is number 43.